Hello Year 9, today we're moving on with triangles. So there is different ways to name our triangles. First of all, we can name triangles by the sides that they have. So here are the names according to the sides. A scalene triangle has no sides or angles that are equal. Okay, to draw a scalene triangle, you got to try and make all the sides look like they're a different length. So maybe something like that. Now to indicate their different lengths, we want to put a different symbol on each side. So I might put one little line here, 2 lines on there, and 3 lines on there, and that means that they are all different lengths. If all the sides in a triangle are different lengths, it does mean that all the angles are different lengths as well. So that means this angle is different to this angle, which is different to this angle. Okay, and the next one we have is the isosceles triangle. An isosceles triangle has 2 sides that are equal, and it also has 2 equal angles that are opposite those 2 equal sides. So in a diagram, I'm going to draw the 2 equal sides up the top here, and then one big long one across the bottom. So if that one and that one are the same, I mark them both with 1 line, and the third one would be different. So I'm going to put 2 lines on the last line there. Okay, that means that the angles down the bottom here, these ones will be the same size. So that's an isosceles triangle with all the correct labeling. The last type of triangle is an equilateral triangle. In an equilateral triangle, all the angles are equal and all the angles are equal, which means that they are always 60 degrees. So let's draw one of those as best we can. So try to make it look like all of the sides are the same length. We put 1 little dash on each line to show that they're all equal, and each of those angles is 60 degrees. Oop, that's a bit messy. Okay, so that is naming the triangles by the side that they have. We can also name the triangles by the angles that they have. So naming by angles, the first name is an acute angled triangle. To be an acute angled triangle, it means that all of the angles in the triangles are less than 90 degrees. Okay, so for example, something like your equilateral triangle, let's go with something like that. That all those angles are less than 90 degrees, so that would be an acute angled triangle. A right angled triangle would have 1 angle that is 90 degrees. So here is my triangle. I'm going to put my right angle down the bottom there. If I put my little right angle symbol in there, it identifies that as a right angle. And the last name is an obtuse angled triangle. This is a triangle that has 1 angle. It's not possible for it to have more than 1. There is only 1 angle that is bigger than 90 degrees. So you would draw 1 big obtuse angle like that, and then connect up the sides of your triangle, and that would be an obtuse angled triangle. Now it is possible to have an isosceles triangle that is also an obtuse angled triangle, so you could actually name triangles and give it 2 different names, 1 for the sides and 1 for the angles. Okay, keep moving. Now we had the angles in a right angle made 90 degrees. Then we had the angles in a straight angle makes 180 degrees. And our next rule today is that the angle sum of a triangle is always equal to 180 degrees. Okay, so we want to find the value of the pronumeral in each of the following giving reasons. So because we know that all of those angles equal 180 degrees, what we can do to find B is start with the 180 degrees and subtract off the other angles. Subtract the 70, subtract the 80. We write our reason in brackets, and it's angle, so using the angle symbol, angle sum of, now you could write the word triangle, or you could use a little drawing of a triangle. So angle sum of triangle equals, so the equal sign, 180 degrees. Okay, so we use standard symbols to make these reasons as short as possible, but please use the exact reasons as I am showing them to you. Don't try to adjust them into something that you're making up yourself. All right, then we still need to find out what b is equal to. So we start with 180, we subtract off 70, we subtract off 80, and that means that b is equal to 30 degrees. Let's do it again for the second one. To find f, because it's a triangle, it's going to start with 180 degrees and we subtract off the other angles. I subtract off 90 degrees for that right angle, and I subtract off 45 degrees as well. Write the reason in brackets. Angle sum of triangle is equal to 180 degrees. Then use your calculator. Okay, so that last line there, f is equal to 45 degrees. In question 3, we actually have an isosceles triangle here, as we can see from these little lines, but that doesn't matter. We can still do the question the same way. To find I, because it's a triangle, the angle sum is 180 degrees. I subtract off the other two angles. Subtract 30, subtract 30. Write down the reason. Angle sum of triangle is equal to 180 degrees. Calculating 180 minus 30 is equal to 120 degrees. Okay, a couple more to do. Question 4. To find k, the angle sum of a triangle is 180 degrees. I subtract off the 30, I subtract off the 60. Write the reason down. Angle sum of a triangle is equal to 180 degrees. And calculate. So it is a bit repetitious, but that is important. So that last angle is actually a right angle, 90 degrees. Question 5, this would be on the harder page of questions. To find the value of E in this question, we've actually only got one angle here. But because we know that this is an isosceles triangle, we know that even if there's a 40 degrees here, it means that this one over here has to be 40 degrees as well. Because remember, in isosceles triangles, that those base angles there have to be the same. So using those properties that we talked about can help us solve them as well. So now to do our working out, to find E, the angle sum of a triangle is 180, and I subtract off the other two angles. Subtract the 40, subtract the other 40, and write the reason down. Angle sum of a triangle equals 180 degrees. Okay, and so that equals 100. So your questions start here on page 16, and you'll notice the first couple of questions are not actually triangles. This is because I need you to remember the rules that we've learned in our previous lessons as well. So this first one is a right angle. You'll have to solve that using the right angle rule. And then B is a straight angle. So solve that for how we did it for a straight angle, and then into your triangles from there. Okay, remember to show your working out and to always, always, always write the reason down.